Warm welcome to everyone who's here, particularly to our participants, our speakers. Thank you for being here. Why do we have the science elective? What is the need for the science elective? And normally we have a science colloquium like this, and in fact, it will lead to some of you opting for the science elective. That is our very fond hope. Why is science important, and why is the science, the topic today is from science to science journalism. I think it was in 1840s that the young Karl Marx talked about why we as a species, the humans, why are we different? How are we different from other species? And one of the things that he said was, the main thing, this was in the 1840s, he was quite young, and he made this statement, which I think is very relevant today. He said that we, as a species, as humans, we're the only ones who collectively, we know to collectively collaborate reasoningly. That is not with magic, not with instinct, but with reason. We collaborate collectively and with reason in order to transform the world around us. And we just have to look around us to know that, this is an excellent definition of what scientists do. This is an excellent definition of what human beings do and what science does. It transforms the world around us, and you see the transformation, you see it in so many different fields. The usual, when we think science, we think physics, chemistry, we think and biology. But it could mean health, and you look at medicine, you look at healthcare, you see the immense changes that have taken place on our planet. You see the way so many things have transformed. It's also true that there are negative points, but it is something that we can collectively change, like climate change. But there are many, many parts that, there are so many constituents of science, including technology. Recently, we had a lecture that we all attended, and that was on AI, right? We had that. AI is also part of science writers. We have had science journalists from many of our alumni are now working in the field of science and writing, making us proud. They are not necessarily all scientists with a science background in college, and they haven't done science. They're not scientists, not all of them. But many of them are doing excellent work, even in data journalism. In fact, today we have our speakers who are here are all people, they are scientists. There's at least Dr. Sitabra Sinha and Dr. Indumati are both scientists, physicists, mathematicians, others, other fields. And yet, they don't operate in an ivory tower. In fact, Dr. Indumati is somebody who, our first speaker of the day, she is somebody who writes for children. She makes science accessible to children. Dr. Sinha brings out a newsletter, which I have looked at, and it's quite marvelous, quite accessible to, I'm not a scientist, but I can access it quite easily, and I'm sure all of you can, right? And Dr. Srinivasan Ramani will be here shortly. He's our third speaker of the day, and he will be talking about data science. Data, number crunching, that's also part of science in a certain way. These are all fields that are accessible to anyone who is interested in the field. And I do hope, as happens every year, we will have a lot of people opting for this elective. So far, the elective has been, for the past, how many years, Shubha? 5 years, yes. We've had Dr. Shubhashree Deshikan, who I will introduce very shortly. Dr. Desikan and Dr. Ramanujam have offered this elective, science reporting elective. And This year we have Dr. Shitabra Sinha, who will be offering it to us in this college. Okay. Um, Let me then begin by introducing Dr. Shubhashree Desikan, to whom we are all very grateful, because every year she has been organizing this colloquium. Even last year we had a half-day colloquium, which was quite outstanding, and I'm sure it will be this year as well. Dr. Shubhashree Desikan has a PhD in physics from the Indian Institute of Mathematical Sciences. She is, but she is presently working as an associate editor with IIT Madras Shastra magazine. She has spent many years as a science correspondent with the Hindu. And she was also taught, as I said, she's taught the elective for 5 years in the college. Dr. Shubhashree, in fact, in 2017, won an award for science communication and print. And this was given to her by the Department of Science and Technology, Government of India. And she wears two hats. She's not just a scientist, not just a science writer and a journalist, but also someone who does translation of Tamil novels into English. And one of her latest, I think, is coming out in print shortly. So thank you all very much for being here. And I will now request Dr. Shubhashree Desikan to introduce the first speaker of the day. Thank you.
Hello to everyone. It's a great pleasure to introduce Dr. D. Indumati, who is a friend and a long time, I've been an admirer of hers. She completed her undergraduate in physics from Women's Christian College in 1983 and then a master's in physics from Madras Christian College, Chennai. After a short stint working on experimental nuclear physics as a PhD student at TIFR Mumbai, she completed her PhD on theoretical particle physics. That is a great shift from experiment to theory that she made. She worked with Dr. Murthy at the Institute of Mathematical Sciences, Chennai, your neighbor. Later on, after her postdocs at Physical Research Laboratory, Ahmedabad, and University of Dortmund, Germany, and a brief sojourn at the Indian Institute of Science, Bangalore, she joined Harishchandra Research Institute, Allahabad as a faculty member. During this time, she worked on particle physics phenomenology, including strong interactions, finite temperature field theory, and nuclear modifications of strong interaction processes, all very fundamental stuff. Before moving back to the Institute of Mathematical Sciences, Chennai, in 1998, where she resumed her work on neutrinos as well as on various aspects of thermal field theory as faculty member. She is interested in science popularization, as Dr. Nalini mentioned, and is the editor of a children's science magazine called Jantar Mantar. She will now speak on scientific temper and the application of science in everyday life. Please come. She will speak for 40 minutes or so, after which we will have questions.
Thanks, Shubha, for an introduction which I think mostly people did not understand. It doesn't matter what I work on. I am just happy to be here, looking at all young people who, whether compulsorily or otherwise, are supposed to be interested in science journalism. So I like to walk up and down. So I think I want to start with what Dr. Nalini said. Humans reason, scientists especially reason, and I want to actually question that. Are we really such rational beings? And if we were really, and I wish we were such rational beings, would science and society be in the particular status that it is today? And I want to look at it with respect to the Indian viewpoint. Okay, so here are some caveats. This talk is going to be a hodgepodge between facts and, in fact, my own opinions, obviously. So I also gave this talk about 2 years ago at this place. I'm hoping that all those students have gone away and this is a new bunch. So there's about 50% overlap, so I apologize to the seniors who are going to be subjected to the same talk again. But these are things which are close to my heart and I think they bear repeating, so I'm going to talk about them again. So this is the outline of my talk, and although it says some thoughts, actually everything are some thoughts. So let's just start with some thoughts, okay? So why am I interested in fundamental science? Like you are all interested in journalism, presumably. Why am I interested in fundamental science? So this has a history which I didn't go back as far as Marx, but I'm going back a little more than 125 years when the electron was discovered. And in those days, discoveries were just driven by scientific curiosity. I think this is an important difference between those days and these days, when I don't have to keep writing project reports and get approval for funding, right? And if I don't do something which the government is interested in, they will not fund me. And so those really, beautiful days are gone, maybe rightly so. But in those days anyway, discovery was driven by simple curiosity. But that electron which was discovered at that time, which presumably had no use whatsoever except, in the interests of a certain bunch of scientists, today I am actually talking to you with the help of electronic devices and computers. And in fact, all of you journalists use this technology so heavily, right? You're no longer using pen and paper, you're all typing away or watching your cell phones when you're supposed to be listening to your teacher and stuff like that, right? So it is this science to technology link that I want to talk about, and especially for the last actually almost 20 years, maybe even more than 20 years now, I have been driven by this curiosity about how easily human beings embrace technology but are afraid of science. This is something that is not limited to India. Again, these are all opinions, by the way, but I think I have sufficient data to back up. If you ask me, I can talk more about it, but I will restrict to opinions because I don't have really time to set forward all the facts before you. But you can look this up. I mean, now Google will tell you all the answers. And I want to tell you something also about when you look up things. Because of AI, everyone's talking about AI. All of you, I'm sure, look up Google. And I'm sure you've seen what Gemini tells you about various things that you look up. But there's one thing nice about Gemini. When it gives you paras of information, you ask, what is an electron? It gives you, say, 5 paras of information. For every para, it gives you a reference which you can click on. And when you click on that reference, you can see, oh, this is from Baiju and this is from Nature. And then what will you decide about the quality or the content? Baiju has never retracted a paper, but Nature has, right? So I leave you to think about it. Sorry, that was just a joke. But the thing is, you can always look up the sources. You should look up the sources. And I think technology has made things much, much easier for you to actually decide, about facts relating to a subject. Facts may be complex, but they are there for you to explore. This is something that is very important difference between when I was your age and how things are today. So anyway, going back to, why am I interested in, can you see my point? Yeah. Why am I interested in fundamental science? I'm going ahead that I said not just my electronics and my computers, but you can see that in 1932, just the partner of the electron, which just has the opposite charge to an electron, something called a positive electron or a positron was discovered, and something's in black. Say what all it meant to physicists, it doesn't matter to this audience. What matters is what is in blue, because now we have PET scans. PET stands for positron emission tomography. I see people photographing this page. I can put this talk out for you to pick up. It's just a PDF file. Maybe your teachers will give you access to it, so you don't have to desperately photograph these things. And a lot of what I say, I have said before. If you find other talks of mine on the internet, you're free to browse through them as well. Okay. So the PET scan is something that was invented as a consequence of knowing that there are positrons, right? Only if you know something, you can ask what use you can make of it. And so you discover the positron, and black things are what is interesting to physicists, but the blue things are actually applicable and interesting and useful to whole of society, right? And not only PET scans, I would like to talk about starting from X-rays to PET to MRI scans. All of you have heard of MRI, but the name of MRI was actually NMRI, because MRI stands for magnetic resonance imaging, but what is resonating magnetically is actually the nucleus. And it was recommended by the body of doctors that you drop the word nuclear because people are afraid of that word. And so all of you only know MRI and don't know that it actually has to do with some nuclear spin, for those who know some physics, processing in an external magnetic field. All of you know that there's a very strong magnet in an MRI machine, but what is actually being affected by the magnet is all the water molecules in our body, because we are mostly water, and that is what does the imaging. And it's the nuclei of these atoms which are actually reacting and responding and giving you these images that you call MRI scans, right? So already you see, as far back as then, people have started becoming afraid of certain catchwords, phrases, keywords, and this is something that seems to be very broad and intuitive amongst large sections of society. Of course, these examples were from physics because I know best about them, but there are, of course, if I was a biologist, I'm sure I'll be able to find examples like this as well. Now that we are in August 1st, how can I miss talking about August 6th, 9th? We all know what happened. In 1920, which is 105 years ago, Aston discovered that 4 protons are heavier than a helium nucleus. This is, I think you can forgive me this little bit of science. Protons are protons. We know that a hydrogen atom has protons and electrons. Helium has 2 protons and 2 neutrons. So the difference between 4 protons and helium is 2 proton versus 2 neutron, and in fact neutrons are heavier than protons. However, the entire helium nucleus is lighter than 4 protons put together, and this is what is due to nuclear binding energy. Okay, it's exactly like when hydrogen atom, proton and electron comes together, and to ionize it, to take away the electron, needs energy. The same thing happens here. That energy there was called ionization energy, here it's called nuclear binding energy, and this discovery actually led to nuclear power, nuclear weapons, nuclear everything, and of course August 6th, 9th culminating in the atom bombs dropped on Hiroshima and Nagasaki. Within a few months of Aston's discovery, Eddington used the results of Aston to argue that hydrogen could burn into helium in stars like the sun. Today we know that is what powers the sun. The sun shines because inside the core of the sun, hydrogen is happily burning into helium, and the enormous amounts of energy it releases. That is an entire talk on its own. Why nuclear transmutations or transformations produce almost 1,000,000 times more energy than what electronic transmutation, that is chemical energy, can produce. Okay, and that is why nuclear weapons are so much more deadly. Almost, actually the factor is 100,000, not a million, but it is therefore much more deadly because gram per gram it has 100,000 times more impact. Okay, so he said that this is how the sun can shine, and this is how the sun has, I saw the sun when I was young and none of you were born, and my father and my grandfather all have looked at a sun which looks very similar to this, right? And that is because the steady state is because of this process, which with very, very small amounts of mass can produce huge amounts of energy. Okay. However, he also said the following, and it was kind of prophetic actually. If indeed the subatomic energy in the stars is being freely used to maintain their great furnaces, of course very poetic language, it seems to bring a little nearer to fulfillment our dream of controlling this latent power for the well-being of the human race or for its suicide. And you can see that, right now I can't even count how many wars are going on around the world, right? And everybody is threatening, I have a nuclear weapon, I have more nuclear weapons. So this is the state that we have brought ourselves to, right? And we know this, what was the consequence? We know the consequence. Hiroshima and Nagasaki, thankfully so far only the 2 places where nuclear bombs have been dropped, already too many. And I want to talk a little bit, especially in the context of Hiroshima and the scientists who were behind this. All of us know that it was the first time nuclear weapons were used, it was the first time nuclear weapons were made, and that there was a whole team of scientists who were involved in actually building the atom bomb and then testing it in Hiroshima and Nagasaki. And I want to spend the next few slides talking about the background to this, because every 50 years, and in the case of in Hiroshima and Nagasaki, after 60 years, the US government actually releases its files, and you can actually go and read what it was that happened at that time and really what happened. Okay, so already Germany had surrendered. This made life very easy for the scientists, because you don't have to drop a bomb on someone whose skin color and racial profile is so close to yours, right? This is for me very clear. I mean, I'm not even going to call it an opinion, I'm going to call it a fact, right? So the European war has ended. The Japanese war is still going on, so the focus has shifted to the Pacific, and you have a target committee, and you can see in red, doctor, these are all scientists, these are all physicists, very famous physicists. So these people were actually involved. It was not the army or the military as much as the scientists who were making decisions on what bomb we will make, where will we drop the bomb. This is at the target committee, right? And so you can please check the documentation. And the agenda, you can see the agenda is also listed. The minutes are there available. Height of detonation, report on the weather, status of targets. psychological factors. So let us focus on the targets. They have to be important targets in a large urban area. What does it mean? Large urban area is a euphemism for many people, right? So this is the first time in the history of humankind that a target has been chosen to be dropped on people who are not directly at the battlefront. I mean, this itself, I think the thought itself is a war crime to which nobody has answered so far, right? They should be capable of being damaged, blah, blah, blah. And then they have to be unlikely to be attacked by conventional weapons before August when they thought that the bombs would be ready. So look at the kind of, so scientists are extremely rational and they went about very rationally planning how to be most effective with this nuclear weapon, right? So there was a list of targets, ultimately that, Hiroshima was chosen and they made this thing. In fact, the possibility of bombing Emperor's Palace was also discussed. They, ran it through threadbare, everything was decided. And then we know that, finally it was Hiroshima, and then Nagasaki by accident. It was not even on the list of targets, but that is all history. We know what it happened and that no one has apologized for it as yet, right? However, on the other side of the nuclear coin, at the same time, within practically a few years of the bombs being dropped on Hiroshima and Nagasaki, you have nuclear power, which today we know as a source of clean energy because it has small carbon dioxide emissions. And this is the percentage of total power production in various countries, and the fraction of that being nuclear. So in India, 3% of all the power that it generates is nuclear, and you can see that we have so much conversation around 3%. Right? You can even shut down all the reactors in India and it won't matter. Okay? UK at 12%, France I think is little more than 60%, and UK looks small, sorry, US looks small, but actually this 18% of production is actually 16 times larger than what India produces. Because it's just huge. The energy production in the US is just huge. But of course, once you come, sorry? No. It's 18% of the total, and the total is humongous. So the total production of power in the US is so large that 18% of that X is 16 times this quantity. Sorry, I should have put numbers. Thank you for pointing that out. Yeah, it's not 3 6s are 18, but 18 of some X, and that fraction comes out to be 16 times of that. Okay, in actual amounts. Okay, so if I produce 1 gigawatt of nuclear power, US is producing 16 gigawatts of nuclear power. But of course, once you say nuclear power is clean, blah, 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 then you have the question of nuclear waste. What do you do with the nuclear waste you're producing, right? And everybody says, not in my backyard, right? In fact, the whole discussion of nuclear power in India is around nuclear waste. What do you do with the nuclear waste? In fact, what is the government doing about nuclear waste? And so, in my opinion, the issue is not so much not in my backyard, because why not in my backyard? You don't have trust in these scientific institutions which are trying to tell you that nuclear power is 100% safe. As a scientist, I won't even believe you if you say something is 100% safe. Nothing is 100%. This building is going to fall on my head. Yes, it will fall on my head sometime. Maybe not today, maybe not tomorrow, maybe in 50 years, maybe in 100 years, but it will fall. If I decide to stay here forever, it will fall on my head. But we say, no, this building is 100% safe. It has been rated as 100% safe. So what a layman believes as 100% and what people who are actually in the scientific and technological community call as 100% are two very, very different things. And for a scientist to say something is 100% safe, I would say you're lying. No scientist should say anything is 100% safe. But to give a modicum of trust in my numbers, to say, yes, we have to deal with the waste, we can deal with it in this way, it can be safe in so and so way, no one has come out and actually made these statements. And that is why there is so much mistrust, right? That this is something I'm going to harp on again and again. When you talk about science journalism, when you ask questions of the government, of civil society, of scientists, this is the thing. At what level do you trust the source that you have? And I think this is the biggest problem that we have in India today. And now see, I'm turning the coin again and again. Sorry. My God, where did I go away? Okay, so here I am. So now we also have radiation therapy, right? No, nobody's afraid of radiation. I have cancer, I rush for radiation therapy. Now I rush to Apollo Proton and get my proton therapy as well, right? So now people are talking about heavier ions, not just why stop at proton, you can go up to carbon, right? So, but that's just nuclear radiation, right? Whereas when earlier people were having radiation therapy, it was simply X-rays, gamma rays, but now you're actually having particles beamed at you. but the public does not fear. So this again is, where is it that the public makes a distinction between nuclear radiation and proton radiation, which is actually the same thing, right? So there is something very intrinsic, very intuitive in the way we look at these, and it's the way in which I think these things are packaged and promoted. If somebody tells you that proton beam therapy is going to cure you of your cancer, I think the tendency to question it is going to be much less than if someone tells you that I'm going to produce power, I'll dump some waste in your backyard, but it should not bother you. See, you see the difference in the way the two are actually framed. Okay, and this continues. There are more examples which impact society, not just nuclear power and radiation. M.S. Swaminathan, who was your neighbor till recently, always promoted productivity in perpetuity without associated ecological harm. Now what does that mean, right? Under him, this genetics division of IARI was renowned for research on mutagens, which do genetic modification and try to improve the crop yield, crop variety, resistance to various pests and so on. So he had a lifelong interest to study radiation mutation, and some of his work was done with the Department of Atomic Energy, which is why I'm aware of it. And for example, food radiation, which leads to pest resistance, shelf life, etc. So there are two things involved here. One is simply radiation. I want to send my favorite Alfonso mangoes to the US, and they are not going to allow it unless it's going to be irradiated, right? So you package it completely, so you don't touch it anymore, no human being touches it, nicely packaged in a cardboard container. Now you can radiate it because the radiation doesn't care for your packaging, right? It will go through and it will penetrate, it will radiate your mangoes or your bananas or your potatoes or your meat or whatever, and only then the US actually accepts it as a cargo, right? So this is simply irradiation because, for example, it prevents the potato from sprouting. All of you would have seen in the humid months in Chennai, if you leave your potato for 3 days, it's already sprouting. You just have to put it back in the ground and you will get a potato plant. So to prevent that, this radiation happens, right? The other thing is radiation-induced mutation. You have a bunch of crops under controlled conditions, of course. You radiate them, you speed up the mutation rate. Because how does mutation happen in nature? We are all born because of mutation. Darwin told us all about it. And various varieties mutate at very natural, slow rates. And this mutation happens because there are cosmic radiation which is coming and hitting the earth all the time. Part of it is protected by the earth's atmosphere, the rest of it comes through. And over time, over centuries and thousands of years or millions of years, mutations occur. And then these changes, sometimes Darwin will say that the survival of the fittest, so whichever was fittest to survive, adapts and then survives. Now you want to speed up this rate of mutation, you can actually induce the mutation through radiation. Now you breed it just normally, you select for it, then you grow it, and then you check what its properties are, and if it's a better yield, then you do that. For example, lot of peanuts, for example, in Maharashtra and Rajasthan are actually these radiation-induced mutated peanuts, and they have very good shelf life, very good properties, etc., etc. However, again, as I said, the other side, because we are always talking of how science can impact society both well and adversely. What about BT cotton and of course also BT brinjal? So these are different things. These are GM crops. GM crops, genetically modified. Actually, you have at the gene level you have controlled it. So it's not a natural mutation that you got out of radiating the crop, but you've actually inserted a gene in that object which has certain properties. For example, in BT, it actually produces, the plant itself produces an insecticide which kills an insect which is called the bollworm. Okay, so brinjal has been, it's actually, sorry, banned is not the right word. It didn't get permission to be grown in India, but BT cotton, from what I could see, between 70 to 80% of cotton grown in India is BT cotton. And now if you read the literature, it's actually pretty frightening because initially, of course, they had to use much less conventional pesticide because the plant itself could combat the bollworm. But then there are other insects in nature, not just the bollworm, and the plant doesn't have resistance to that. So over time what happens is that the bollworm itself gets resistant to this mutated gene, and then the other insects that are there also take over, and then again you have to now spend on conventional insecticides. Okay, so the question of how do you actually decide that something that you think is good for the plant or for your growth or for agriculture or for the society ends up not harming other things, because these are two different issues. One is the scientific issue. because of course if it's brinjal, then of course you're going to eat it, so what is the impact on human health? This doesn't happen with cotton, but it can give you allergic reactions, there can be pesticide resistance, other insects can be impacted, secondary pests as I talked about can grow. You can see that because it's genetically modified, if it, you can also have the spreading through the non-cotton population around, so the biodiversity can be affected and so many things. Of course, then of course there's the issue of herbicide tolerance. I think now glyphosate has been talked about for a long time, government has finally banned it, but this doesn't happen unless there are studies which show you that this is bad for you, right? So this is all technical issues, whereas there are social issues, right? We all know that it was a multinational company which was promoting BT cotton, right? They have control over the crop, they have control over the seeds. You can only buy, the farmer can only buy the seed from that particular multinational company. So what is the impact on small farmers? What do you do with traditional seed varieties? And of course, because these are very big multinational companies with a lot of money power, what is the transparency of the regulatory process? There is none. And of course, there is a lot of potential for conflicts of interest. So you see that every one of these issues is actually something that a journalist can write about, can find out about, and inform society about. And the second thing is that these are all very complex issues. Today, the kind of technological issues that are facing civil society is not something that even an educated scientist can make a decision about. They're extremely technical, they're extremely sophisticated. And I can find 100 papers which tell you that BT cotton is the greatest thing in nature, and I can find 100 papers which tell you that it's the most horrible thing in nature, right? So it is becoming more and more difficult. I hope I don't put you off from this, but I think it's like a detective agency, right? You have to go deeper and deeper, you have to find out more about it, and I think the challenge is actually to find that right balance, how to appreciate these issues, how to make the public understand, communicate it through language that they actually know and feel comfortable with. I think that is really the challenge. Okay, so here I have a lot of, I think Gyan. It's already clear that an independent, dispassionate assessment of discoveries and decisions related to science and scientific technological issues is indispensable. It was always so, still is, and is the need of the hour, and particularly so in India. Scientists cannot assume their research has no impact or only positive impact on society. They must engage with society. And here journalists have a crucial role to play, because to be a science journalist is not just understanding the science, but understanding how the scientific process works, and that scientists are not necessarily rational, dispassionate human beings. I think this is very important. We are human, all of us are human. We have our, blinkers on, and there are always some things which we are not going to realize, that we don't understand or don't appreciate, or our little pet projects which we are unwilling to give up, right? So unfortunately, scientists, especially in India, have no or few fora, voices or institutions which can disseminate information and offer even technical inputs to governments and shape decisions. For example, Department of Science and Technology, Indian Academy of Sciences, using various policy documents. This is completely in contrast to, for example, APS, which actually generates so much policy on science and technological matters. Such an institution must be seen, I am telling you doesn't exist, must be seen to be even-handed and most importantly independent, with good credibility that of course needs to be built up over time. So what am I saying here? That we don't have such things, right? We don't really have. How do you trust when a scientist tells you, I'm also a scientist but I'm wearing a different hat right now. How do you trust when a scientist tells you that something is true or not? How do you believe when the government says, this is really true, or this is just a party line that they were forced to speak, right? This is something that I think all our institutions really lack, and I think we have to take this very seriously. If people must trust in us, then I think this is something that we should build. We should build more rapport with journalists, that over time we should gain their credibility so that they can see what we are doing and why we are doing it, and only then things can change. Okay, so that leads us to critical thinking. Science journalism requires a robust understanding of the scientific process, not just the science. In fact, you can always learn the science. You people are going to be journalists in so many areas, something new that you don't know anything about, right? You can pick up the key matters of concern, but you must understand the scientific process. For example, double-blind trials for drug approvals. How are drug approval tests done in India? I think you will be shocked if you actually go and look and see what they do, okay? But science journalism is a bridge between scientists and the general public. It should primarily inform, And this is again a very strong opinion of mine, it should leave intelligent citizens to join the dots and draw their own conclusions. I think it is not correct for a newspaper to say this is such a great thing or this is such a bad thing, because I think the job of a journalist is to put out the facts there. And in fact, with the same facts, people can come to different conclusions. Definitely possible for it to happen. So it should be able to present in the event of a controversy both sides. For example, of course, this is a very easy solution in my opinion, nuclear weapons versus nuclear power, but I just took it as an example. This is something that I think has become very important today, but I have only 2 lines on it. The issue is compounded by social media, the short attention spans of both children and adults. I think because of Twitter and Instagram and things, unless you can write your thing in, like 2 lines, nobody is going to read beyond that. So I think it is also becoming a challenge that you should all be aware of. When you write a long article, whether it is in science or any other topic, who is going to read it? Increasingly, I get very irritated when I click on an article and it tells me 3-minute read, 8-minute read. I mean, who are you to tell me that I should read this article in 2 minutes? No, I might want to spend longer on it. So this is the challenge that people are being pushed into reading at a very superficial level. How do you gain their attention? Like I have 40 minutes. How do I hold your attention for 40 minutes and you don't want to know whether your friend called you on the phone or not, right? It is becoming a huge challenge, and I think it's only going to get worse. You are still of the generation didn't have a phone when you were 2, but soon within the next 10 years that is going to be gone. Okay. And I see this in my own college. I don't know about your experience. My students don't want to come to class. They say, why don't you give an online talk? I'll sit in my room and listen. But that becomes, second level. There is no interactive effort at all, right? Because when you're listening somewhere else, you can't interrupt and ask a question. You can't have a discussion about something that, or you can't contradict or discuss what I am saying. It becomes a very passive kind of an effort, right? So this is something that is becoming a very huge problem today. And also the fact that because of AI, the moment you read something, then that's the kind of stuff that AI is going to feed you all the time. You think you're reading the news of the day, but you're not. You're reading the news that AI thinks you want to read. And this is also something that is very hard to break. No one is going to break it because it is not in the interest of the people who own these sites to actually do anything different. And you have to also then find, that's why you have all these very catchy titles in the article, and sometimes the content doesn't even reflect the title itself, right? So this is something that you have to, and this has nothing to do with science. This has to do with technology. This has to do with the ways news is now presented, to the general public, right? The other thing, of course, as I think I already talked about, is the complexity of current scientific and technological discoveries. When you want to write about these things, for example, I just took the Nobel Prizes in 2024 on the physics, chemistry, medicine, and this thing, artificial neural networks, protein structure and design, post-transcriptional gene regulation, how institutions affect prosperity, and opposition to nuclear weapons. I think opposition to nuclear weapons was great. I mean, everybody could understand it. But when you say post-transcriptional gene regulation, I mean, you can't even understand the title of what the Nobel Prize has been given for. It means that we are far beyond the times when we are doing very simple kind of research. No, now research itself has become so technical, so detailed, and so difficult to understand, right? It becomes even more of a challenge. Since it is already advertised that I like to write for children, this is 2 years ago when in 2023, when the Chandrayaan-2 was so successful, we had a lot of brainstorming about, because see, maybe I should give a little 1-minute background. So I write for Jantar Mantar. It's a children's science magazine which is brought out by Tamil Nadu Science Forum. So I have been part of Tamil Nadu Science Forum for almost 40 years now, and its whole it's geared towards science popularization among children, among the general public. So it takes up issues like science writing for children, nuclear weapons, BT cotton, BT brinjal, all these issues that are of relevance to society. And it talks about them, and we are of course self-funded because nobody wants to fund us, right? But because of this, at that time when Chandrayaan happened, there's a lot of discussion from the government side about how to popularize science for children, how to make it interesting for them so that more children come into science. Okay. So what is it that we do in our textbooks, right? So we actually give children a bunch of facts, right? This is what they learn, what they call science in school is actually a bunch of facts. Earth goes around the sun. The sun is much bigger than the earth. We are part of the Milky Way galaxy, something, 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 okay? So how do we know this? How was this discovered? Is there a simple way of actually finding out or believing in this independently, right? How do we teach them to understand this fact and not simply transmit it to them as a fact, right? Do we simply ask them to believe? So I don't have time to show this to you. I want you can find this on Wikipedia. This is the orbit of Mercury. So this is the orbit of Mercury going around the sun. This blue, I hope you can all see the blue, is the orbit of, if you can't see it at the back, can someone switch off the lights here so that it is more visible? Or you can look it up in the lights of Pandamudiyuma. I think, yeah, is it better? Yeah. So now you can see that the small orbit of Mercury, and this is the orbit of Earth. But now you see, if you ask where is Mercury with respect to the Earth, because we are all on the Earth, right? You can see that this is where it looks that Mercury is, right? So either Mercury is on the far side of the sun or the same side of the sun, and it looks like it's going in this very funny orbit. So in middle, Mercury actually seems to go backwards and then forwards again. So how does a planet suddenly move backwards? It's not reversing, right? It's not a car. So then people realize that the Earth is not at the center of the solar system, but the sun is at the center. And then if you redraw the thing maps like this retrograde motion of Mercury actually proves to you that the sun is at the center of the solar system. Now this is not very difficult for a child to understand. It is never taught. So why is it that we are afraid of teaching? I have heard this many times. No, we will add this in the syllabus. It is very interesting. We will remove the derivation. Why are we afraid of allowing children to figure out how or why something is done, right? We don't want children to think. We just want to present them with a bunch of facts. I think this is something, So for example, if you allow children to think, for example, like by serendipity, Alexander Fleming discovered both lysozyme and penicillin, or de Mestral discovered Velcro, right? He had a dog with very shaggy fur, and that was it, whenever the thorns stuck to him, stuck to the dog, he got irritated, and then he actually used that to invent Velcro. So where is the joy of doing science coming through in our books? This is something that I think that is why forget journalists, even the children don't want to do science, because it is something that they find extremely difficult, right? Because it is not something appealing at all. Well, I can skip this slide. Mathematics is also important, but I don't want to. Okay, maybe since I've shown this, this is the sun, this is the earth, and this is the moon. So the sun they are not in proportion, of course. Sun is very far away from the earth. But if you look at the stability points, because two bodies attract each other, so this point L1, the force that the sun exerts and the earth exerts are equal and opposite. Similarly, when the force that the sun exerts and the earth exerts are equal and opposite. So these are called Lagrange points. And you need very little energy to actually stay at the Lagrange point, because it's a point of stability. So if you see this over here, this is the James Webb Space Telescope. It is put at the Lagrange point. So it can stay forever, it can stay for a very, very, very long time, and it is taking data of the universe, right? Similarly, you have heard of the Aditya space probe. It will be at the inner L1 point so that it can observe the sun. So this is something that is so easy to understand, right? Why don't we actually talk about this and put it in the newspapers and say, look, it is here. And then people will understand what gravity means. Two bodies, when they attract each other, at some point there will be a zero because the two forces balance. But this is something that we don't teach maths as a part of the language of science. We are even more afraid of maths than we are of science. And this is something that we can make actually a lot of fun. We can make it very interesting. So, as I said, in 2023, they had this mandate to generate material for popular dissemination. And the NCERT brought out something called the Chandrayaan modules. You can go and look it up on the net. And I'm taking some extracts from there. Okay, and I think I will, these are just some sample comments. You can find them here. So for example, so I'm mostly taking secondary stage, that is 9th, 10th, 11th, 12th standard material. The text says, Chaitra month is named after Chitra Nakshatra transiting the moon during the period. Now, does the nakshatra transit the moon, or is the nakshatra far away and the moon transits in the foreground, right? Now, there's something even more interesting. The shape of the velodrome is like a frustum, which is a sliced cone, is leaving its vertex like a bucket. Tell me anyone understood this. Just raise your hand if you understood this, then you are really a miracle actually. So what does this mean actually? Here is it. Here is your bucket. Take a cone, slice off the top, and then the shape is the frustum. Now why couldn't they just put a picture over here and explain, right? And then so on. I mean, there are questions on correctness, comprehension. For example, okay, I will skip this. I mean, there are many. And look at what it says here. As we delve deeper, this is for the grade 11-12 standards, as we delve deeper into this cosmic odyssey, we cannot help but be inspired by the indomitable spirit of Wernher von Braun, father of rocket science, blah, 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 his towering achievements, blah, blah, blah. And with that, we conveniently whitewash the fact that he was a Nazi scientist who built missiles for Hitler. Right? Couldn't we find any other example? I can't believe it. Anyway, so I think I've given enough examples. I hope I have convinced you that today things are complicated and hard. It does not mean that we should not report about it or not think about it. So I want to kind of end with some certain thoughts. And since I'm a scientist and I don't know much about journalism, I am going to try to restrict it about science and scientists. Science journalism can be complex because of the technical nature of the content, but I think we should be very aware that it is also political, just as much as history or politics. Let us not like convince ourselves that, oh, I'm only reporting on science, science has everything to do with facts. No, it's extremely political. And even what you choose to report on, that choice itself is political, okay? And I feel that in today's world, it is important to be aware and then to go ahead and report, okay? Because we should not fool ourselves into thinking that, you know, this is scientists, oh no, I have no political affiliation, I have no religious affiliation, I am just a pure scientist, is all bunkum. Doesn't happen that way, okay? Scientists have done a poor job, I think I am entitled to say that, having been a scientist for 40 years, have done a poor job of defending their work in the Indian context. Here we are far behind the West, where science popularization and science outreach among both students and general public is in a very advanced state. So I think this is an exhortation to scientists. I'm happy to see scientists here, and you know, I am very happy that ACJ regularly calls us to talk to people, because I think we have to reach out, and science journalists are extremely powerful in their ability to reach out to the general public about science and science issues. And so this is something that we have completely lacked. Scientists have not been able to reach out to either the general public or to policy makers. You see our helplessness. It's not as though, you know, we are able to decide on policy either. I mean, we are not able to do this either. In fact, who are these science policy makers? I have never met one. Why don't they engage with us, right? The science policy is driven, I don't know how. I mean, it's completely opaque. This is something that we have to be very aware about. There is no long-term vision. There are no easy answers. So I think critical thinking with very high levels of integrity and a willingness to abandon promising research if in conflict with nature in the context of today's, you know, world, climate change, pollution, various things are very crucial aspects. So our world, our society today has many complex science-related issues, as I said, state of the environment, climate change, the embracing of technology with associated fear of the science, which I have talked about, ethical issues in the field of medicine, so many things which desperately need information dissemination and debate. In short, needing science journalists. So I hope this is a call to people to take up science journalism very seriously. And as I said, the details of the science depend on the field, but the scientific approach is critical for all types of reporting, whether it's about physics or chemistry or biology or technology. It has to be fact-based, evidence-based journalism, and also the style of writing. I want to give an example here. This was last November when it rained so much. Tamil Nadu rains, over 13,000 hectares of paddy crop inundated, says the minister. So, okay, I feel sorry for those who lost their crops, over 13,000 hectares, but what does this headline in a newspaper tell you? Was this a huge amount of inundation? Was it a small amount of inundation? What will you assume? What will the layman assume when they read this? That there's huge devastation, right? Now I looked up What is the total acreage under paddy cultivation in Tamil Nadu? It is more than 20, it's 21.6 lakh hectares. So what has gone underwater? Not even 1%. As I said, I feel sorry for the farmer who lost his crop. But this is, I think, unintentionally done, but certainly misleading, right? So when you report something, it has, yes, you're asking something. Oh, when you report something, it has to be in context, right? I think you have to be very aware. As I said, when we say nuclear power is 3%, but the debate has been like 2000% about it, right? We have to keep in focus these facts, right? So science journalists can act as a collective conscience by asking the right critical questions and holding up a mirror to scientists. And in today's world, I think this is a real challenge. And I leave you with this. Thank you very much for your patience.
Yeah, good morning, ma'am. I am Archie. Thank you for the talk. It was really illuminating, and it was a pleasure to listen to you. My question would be, it's a bit long, but yeah, the one pertinent question. Yeah, I took a bit. Yeah, the one pertinent question which has bothered intellectuals, scientists, philosophers, and curious Homo sapiens since the dawn of civilization is, why does anything exist instead of nothing at all? The most cited theories which explain these well are the theory of relativity, the Big Bang theory, and the newer and much more dynamic string theory. Yet they all disagree with one another in spite of explaining things individually quite well. In this context, is reaching a unified theory of quantum gravity just a mirage given the cost and time constraints, or shall we get there eventually someday?
The question he asked was why. Okay, physicists don't ask why. Why does an electron behave like this? Why does a proton, why do 4 protons burn into helium? No, I think that is philosophy. Physics asks how. How does this happen? The universe is given to us. See, mathematicians are not bound by this. It's a very important difference. I'm glad you brought this up, because for mathematicians, they can imagine a universe in which 2 plus 2 equals 65. Fine, I mean, they have the rules, and then they will go by the rules. We are trying to explain, we meaning I am a physicist, always think as a physicist, we are trying to explain the universe as it exists. Okay, so why does it happen? No, I don't know. I don't think that is answerable within physics. It is metaphysics or philosophy, and if you ask a philosopher, I'm sure they will have an answer, and I'm sure there are multiple answers, there is no right answer, but that is again an opinion of mine, it's not a fact. Okay. The other thing you asked was very specifically about the Big Bang versus string theory. See, these are attempts to not to, okay, very quickly, I talked about electrons and protons and how they are held together by electromagnetism. I talked about nuclear binding, which is the nuclear force, okay. There is another force which permeates all of nature, which is called a weak force. So every particle experiences it, and then there is gravity. Now it turns out that people are not able to put gravity into a quantum framework. I have not told you what is quantum, but everyone is talking about quantum information, and quantum has become the word. I think you should all look at it, because how many crores has been given for the quantum mission. We are now in mission mode. 6,000, okay, some incredible number of crores. So I think all of you, it's time you learned about quantum, but we are not able to incorporate gravity into the quantum universe. This is our lack of understanding. So people are trying many theories. It's not that they're in contradiction with each other. It is that in trying to unify it, if you're not yet successful, you must try many ways, right? So that is the answer. I don't know whether it satisfies you, but the answer to your question is that these are all different attempts to bring gravity into the purview of quantum mechanics. And there are technical issues with it, which is why we have not succeeded as yet. But it is a very open and very important question in physics.
Hello, my name is Prakhar, and I have 3 small questions.
Okay, please ask them one by one. I'm old and won't remember. Ask them one by one.
There's just 3 short questions. You talked about the NCRT books. So I want you to elaborate on the NCRT science book conditions, because we see history books are being degraded now.
You said it, I didn't. Okay.
So I really want you to elaborate on the condition of science books. Is it good, or it is being degraded in the same way? Second is about the BT cotton you told. It was a new term for me. So can you elaborate on that and tell how it is killing the soil, or it is good for the farmers? And the last question is, India is very low on the nuclear power, just 3% as you told. So why is it that low, and the waste that is being produced by it, what are we doing to manage that waste, rather than answering it not in my backyard?
Okay, so I think a lot of perception, see, unlike, okay, let's not say unlike, let's not get there. Let me start with your first question about NCERT textbooks, right? So every few years the NCERT textbooks get revised. There is a committee which looks into it. And as I said, these are political decisions that are made. So I think the science and maths textbooks are more or less unscathed. I will not answer for the history and other stuff, okay? But science is science, and maybe you can insert a few things here and there, but on the whole, I think the NCERT science textbooks are pretty well written, and they have not been like too much modified. But it is true that in other cases, certainly there has been a lot of modification, because there was a revision committee, and then they have massively revised many things. So
Something about evolution being taken out and things like that.
see, that is a very small part of things. I mean, taken out is much better than putting facts which are wrong. No? So as I said, I don't want to go into it further. But yes, we have to always be aware that these things are happening. And I think, I mean, for example, Tamil Nadu Science Forum writes a lot about, raises these issues in the public domain. And I think everyone should also be aware of these things. And like if you have a younger brother or sister studying in school and you happen to look at the book and you realize that something is missing, I think you should raise these issues. I think that is how it happens. There's a very fairly detailed review of the revised NCERT textbooks, which was brought out by Tamil Nadu Science Forum about 4 or 5 years ago, right? I mean, Jam was also part, Ramanujam was a part of this. So a lot of people are, S. Krishnamurthy, he's also part of this. So there are a group of scientists who are working on it and keep bringing out the material. Of course, these people don't have much reach, and also a lot of stuff they write in Tamil. So you might not have seen it, but it is there. So that was your first question. Your second question was about the BT cotton. So BT, I don't know what exactly you want to know, but I can tell you this much in very short, because there's literally hundreds of this thing. Here, I want to be here. So for example, what happens is that these are the issues. See, the BT cotton has a gene which particularly kills this bollworm, PBW bollworm. Now, if you say that that's the only insect in existence which is ruining your crops, then you are in a beautiful world. Then you're going to get huge cotton yield, right? So since these are expensive because you have to buy it from the company and they sell it in dollars, the additional investment is worth it because you're going to save on other insecticides, right? That is the way in which this was sold. And this was true in the first few years. If you look at a lot of the papers at that time, this was I think 20 years ago. So if you look at the early papers, yes, they had better yield. They had, they did not make more money because they had already spent it in buying the seeds, but they were happy. And that is why today about 80 to 90% of cotton that is grown in India is BT cotton. But over the years, what happens is that the insect also learns to adapt, and there are other insects because you're not putting that much pesticide. Those other insect populations are growing, and so they are eating the cotton instead. And so what has happened is that now the farmer is also spending money buying the seed and is also spending money in this insecticide, right? So now, as I said, now if you read more and more detail into it, there are many serious studies which have gone into it, because now there is hardly any cotton which is grown which is non-BT cotton, right? But you can see that there is, if you just go to your Google and ask what is the yield of cotton per hectare in India, and you will find that it is probably 1/4 of the Western world. So why is it that they promise the yields will go up, right? Because nothing is eating your cotton, you're going to grow enormous amounts of cotton, but it's not happening. So they're not getting less yield, but they're not getting more yield either. And they're spending more money. Now, is there a connection therefore with the, Yavatmal and farmer suicides? That is an even more complex question. I am not prepared to say yes or no. I think there are many factors which go into it, and it is worth a serious study, okay? But these are issues that I think are important, about science and society which we need to take up, because this is not science, right? There is so much political and economic involvement in this issue, so that you have to look at all aspects of this. That is what I am trying to say. That today's issues, when Thomson discovered the electron, life was much simpler, right? Today life is extremely complex, and we are living in this world. We have to deal with it, right? I forgot your third question was?
It was about why India is nuclear waste and nuclear power. Why India produces such a huge power, what are they doing to manage that?
Yeah. So I am employed by the Department of Atomic Energy, full disclosure. But as far as I'm concerned, India's nuclear power there are two issues, right? One was because in 1998 we tested our nuclear weapons, Pokhran, and even in 1974 we tested our nuclear weapons, that was Pokhran 1, and therefore there were sanctions on India. So all our reactors, you know that Kalpakkam, I don't know how many of you know that Kalpakkam has a nuclear reactor, 2 actually, and so these are called CANDU reactors. They are Canadian reactors. We got it from Canada. Canada has huge amount of nuclear power, by the way. So we just bought them lock, stock and barrel from Canada, and we are running them now for I think 60, 70 years now, a huge amount of time. They're working very high efficiency. All our nuclear power reactors work with 80 to 90% efficiency. They're very good actually. So, but the thing is that because of sanctions we could not buy. Canada decided they won't sell us anymore. And in 1998, the whole world decided they won't sell us anymore. So we have to make our own. But when you make your own, like you hear about Make in India, what does Make in India mean? Do you bring the parts and assemble it, or do you do first principles R&D? First principles R&D of a nuclear power reactor is not easy because there are so many checks and balances that you need to do. And there is one that was started R&D work I think when I was a graduate student about maybe 40, 50 years ago, and now has come into production stage. That is the sodium reactor in Kalpakkam, but it's a small one. It is still not a very big one. So this has its own lifetime, its own problems, especially when no country is sharing technology with you, right? So what did India try to do? We tried to import. For example, all our Colloquium reactors are from Russia, right? So now you start to import the reactors. Now you have two problems. One is that suddenly, because there is no R&D, there is nothing local here. Suddenly the population hears that in my backyard a nuclear power reactor is coming, and then there are enough doomsayers who will tell you that, the whole thing will explode in Russia, that reactor exploded and so this reactor will explode, not even seeing that the technology is very different. So it's actually very simple to see that these are extremely safe. They have different levels of safety compared to the one in Chernobyl which exploded. There's absolutely no comparison. But how do you explain this to a layman who may not even have high school education, right? I think that is where even the government really didn't do a very good job in the beginning, and the opposition built up to such an extent that everything got very delayed. Of course, now all the Colloquium reactors are working. But now you ask the question that once these things start coming, you want to buy one from Russia, you want to buy one from the US, you want to buy one from France. So who are the technologists who are going to maintain? Because 5 years they will give you warranty. After that, what will you do, right? You need a local guy who will repair your reactor. So you have to start generating the manpower who will maintain these machines. And that is not easy, right? How many of you want to go and work in nuclear power companies, right? So it becomes now a matter of perception. This is not something that a young child who's finished school or college would like to go into. It's not an area that they would like to go into because social perceptions are so negative, okay? So it will be very hard for the government now to push many reactors. See, also reactor has to be near the sea. So you cannot put it in, some remote place in Rajasthan or somewhere. It has to be on the coast somewhere, right? Needs water for cooling and things like that. So there are a lot of difficulties of this nature, and then it becomes hard. So.
Hello, ma'am. My
Yeah.
name is Nivedita. You were talking about how the N was dropped from MRI, right? That was actually very eye-opening to me. So, a question related to what you were talking about that. So, I just want to put you in a hypothetical situation right now. If, let's say, there is a new tech coming in, right? And
There is
people
a
know
what coming in?
a new tech, a new technology. If it is coming in, and people know nothing about it, and it's not as like how do as journalists, how do I approach the story? Like how do I put forth the facts in front of the people that it doesn't add to the fear, but just simplifies the fact for them, just key pointers?
Well, I can tell you that I tried this and failed also myself. We had a new proposal for a neutrino lab, which we tried very hard to get, but there was so much public opposition because we could not convince people that it was safe, okay? So it is very difficult to do this. But I think that is where I realized that we need to have a lot more interaction between journalists, because see, when I try to reach out to people, it is not possible for me to hold down the job and reach out to more than say, I probably have reached out to some 10,000, 15,000 people. But even Tamil Nadu is made up of many more than that many people. So we have to reach out to journalists. I think a bond between journalists and scientists is very important. So once you know that there are these 1, 2, 3, 4, 5 people whom you can regularly talk to and get information from. When the new technology comes in, you sound out all of them and then you get your inputs from them and then you can explore further. So I think this is what I keep harping on, that this interaction is it's a kind of mutualism, no? We need you and you need us kind of thing. And especially I think we need you because when something like this happens, it is the role of the journalist which will succeed in either telling the people that it is safe or that don't have anything to do with it. Right? So it's a very nice question and very relevant for all of you.
I just wanted to ask, science can be used in a way of a media trial there, in the way that it can shape.
Sorry, say it again slowly.
Different inventions can be used to show in different types of media trial. For example, Ozempic was not made to lose weight, but media reports made it seem like it's to lose fast weight, and that has shaped so many people's understanding of what Ozempic is.
Yeah, but this is again, as I said, it depends on your media feed, right, today. So whether you believe that,
but that's
works or doesn't work,
oversimplification.
no, I'm telling you, this is a very dangerous trend today, you see. I mean, if, I have actually done this experiment. I did 3 days, just 3 days, actually, maybe not even 3 days are required. Just reading, when I get my news feed, I just read articles on weight loss, okay. Now it just floods me with weight loss articles, and most of them fake, 99% of them are fake, okay. In fact, during COVID, I had lent my laptop to my daughter, and when I got it back, it's only K-drama, So, I mean, so this is what AI does for you, right? So you have to be very careful. See, Ozempic, so you go to sites, health sites, you go to Cleveland Clinic, they will tell you about side effects of Ozempic. There is no problem at all. There are enough sites, but you should know them, right? So that is what I said. As I said, you should go ask Google, ask Gemini. Gemini gives you the links. You can go and see whether they are kosher or not, right? This is something that we have to do. We have to go to the sources. We don't need to read the entire article. I also will not be able to understand, but at least abstract and conclusion we can read and we can make up our minds whether this is true or not, right? I mean, and in fact, this Ozempic story, I think youngsters in India are actually asking the question, can I take Ozempic? Maybe they are, 5 or 10 kilos overweight and they want quick fixes, right? And the way media is pushing it, it's, like scary. I mean, it's not just Ozempic, by the way. Maybe I'm overcritical of fashion, but now there seems to be a certain body type among women, and if you don't look like that, it gives youngsters anxiety, right? So these are some things that, this is also science, by the way, because now under the knife I can change the shape of my nose, my eyes, my face, everything, right? And is this something that we want to promote? This is also a question that journalists should be asking. It has become the norm, right? I mean, the actress comes, yeah, I did this, I changed my nose, my ears. No, I got pointy ears. I mean, very hard. Yeah. So I think, as I said, there is no shortage of things to write about for journalists. It's how deep you go and how you present the matter, that is important. Yeah, somebody's phone needs to be silenced there. Yeah, I think I enjoyed talking to all of you. I hope that some of you at least will become science journalists. And India actually does some nice science, and it's high time that got put out there. So, I mean, Shubhashri knows, she has been covering science in India for a long time now. So I think we don't do justice to it, but there are also problems with the way the scientific establishment works, and I hope that that also will be addressed. It can only come from pressure from all of you, right? So thank you very much, as usual. Pleasure to be here. Thank you.